Welcome back to day 7. We are now specifically going to look at how to count the total outcomes. This is a really good skill to have as we are building our foundation for being able to find probabilities of things. In order to find probabilities of certain outcomes happening, you have to know what the total possible outcomes that exist are before you can calculate a probability. So think of this as building the foundation to then be moving towards learning probability concepts. Okay, we are on page number 92 of the course packet under day 7 content. So thinking through possible outcomes, you could probably answer these questions really easily. How many possible outcomes are there when a coin is flipped? Heads or tails? When 2 coins are flipped, it's a little harder to think through at first, but there are actually 4 possible outcomes. You could have heads, heads, tails, tails, heads, tails, tails, heads. When 1 die is rolled, there are 6. When 2 dice are rolled, this one is a little harder to think through, but think about that the 4 came from 2 times 2. There's going to be 6 times 6, or 36 different possibilities, ranging from 1, 1, 1, 2, 1, 3, and so on, right? When 2 coins are flipped and then a dice is rolled, this one might be a little harder to think through. 2 coins, 2 options for first coin, 2 options for second coin. A dice has 6 choices, so it would be 2 times 2, which is 4, times 6, which is 24. And these last couple are really to getting at the fundamental counting principle. And this is the biggest idea in counting that we want to be really sure that we understand. So the fundamental counting principle says that if there are m ways, so like maybe 5 ways that one event can happen, and n ways that a second event can happen, maybe it's 5 ways for the first one and 7 ways for the second one, there are then m times n ways that both events could happen. And there are that many possibilities of what could happen at the end of it all. Think about it, my common association with this principle is making sandwiches. If you have 2 choices for bread, 3 for meat, and then 4 for cheese. A very common way to see the fundamental counting principle is with a tree diagram. So you would have your 2 bread choices, bread 1, bread 2, your 1, 2, 3 meat choices, followed by your 1, 2, 3, 4, let me just get a different color, 1, 2, 3, 4, cheese. Notice it gets a little kind of messy towards the end of it. But these branches are representing different possibilities. So this, and this is one sandwich possibility. However, if I went down this path, and this path, that would be a different sandwich. And so the total different sandwiches I have are how many bread, how many meat, how many cheese, which would be 2 times 3 is 6, 6 times 4 is 24. And that represents how many specific endings, how many different paths are possible as I look through my tree diagram. And so that kind of builds at the concept of multiplying to see total outcomes. So here is an example. If a bag contains a penny, a nickel, a dime, and a quarter, a second bag contains $1, $5, and a $10 bill. If a coin and a bill are selected at random, how many total different values are possible? So remember, you have your first choice and your second choice. Your first choice has 1, 2, 3, 4 different amounts. Your second choice has 1, 2, 3 different amounts. So there would be 12 different possible pickings that you could do. Remember, the tree diagram would give us a different way of seeing it. You could see your 12 using a more visual method if you prefer. Okay. Like I said, I always think of sub-shop examples, so of course I made a sub-shop example. So I want you guys to try out number 2 and number 3 on your own. Go ahead and pause the video, work it out, unpause to check against your answer. Okay, here are your answers for number 2 and 3. Number 2 is pretty straightforward. Number of options for sizes. The cheese or no cheese means that there are 2 choices, right? To choose cheese or not to. 5 options for bread gives you 20 sub-choices. For the dice problem, if you want to look for numbers that are 400, that are greater than 400, you only have 3 options for your first digit, because it would have to start at a 4, a 5, or a 6, right? It would be like 4 blank blank, 5 blank blank, 6 blank blank. And then past that, once you have the first number established, the second and third numbers can be anything, right? You're rolling a die, so it's 1, 2, 3, 4, 5, or 6. So for the next 2 spaces, you have 6 options for each of them. So 108 total when you multiply. Another really common possibility with fundamental counting principle problems are license plate problems. So license plate problems generally deal with thinking about total number of integers and total amount of letters. So for the English alphabet, letters A to Z means that there are 26 letters. And for numbers or digits, you have the numbers 0 through 9, which, remember, it's a little weird. There's actually 10 numbers when you think about that. Because if you did 1 through 9, that would be 9, but adding in 0 gives you a 10th digit. And then typically these problems have some added language that you really want to be careful about. Generally, they talk about being able to repeat and not being able to repeat. So being able to repeat a number means that, I'll look at the first one with you guys, and then you guys can try B on your own. So we are doing an investigation on license plates, and she wants to find a suspect using license plates. And the license plates have 5 spaces, 1, 2, 3, 4, 5. The first 2 are letters, and the next are numbers. So if you can repeat, there are 26 letters in the alphabet, and then even if I've used A for the first one, I can still use it for the second, so you still have 26. And then I believe there were just 2 letters, followed by numbers, which there are 10 number options. If I can repeat, there are still 10 for the next slot and 10 for the next slot. I'm not going to write out what this final answer is. You can easily multiply it out in your calculator. The thing I'm most concerned about is knowing to be able to write out that. So make sure for the counting outcomes, you guys have to show this step before writing your final answer. That will show to me that you understand where everything is coming from. You understand what has to be in each slot, you know, based on can you repeat them, can you not repeat them. So try out B on your own, and then unpause the video when you're ready to hear the answer. So for part B, you can't repeat. It would be 26, 25, 10, 9, 8, if I'm not allowed to repeat anything. So notice it goes down 1 each time. And like I said, you could calculate this on your calculator. I'm just going to leave it as this, because this is really the most important thing I need to see in your answer. So that is it for our counting outcomes. This covered the fundamental counting principle. So big idea of this video was the principle on that previous page, which just says you need to multiply the different possibilities for each choice. The practice problems we will look at tomorrow as a class. The last video you guys have to prepare for tomorrow's class is casework. This is just kind of how to organize your counting, specifically with a lot of shape problems. These are pretty common in competitions. So go ahead and move to the last video for today. I'll see you guys then.